Okay, so let's solve this problem. So this is our acceleration problem. We have a body, so it is traveling from point 1 to point 2. It actually started somewhere at point 0. So then after 2 seconds, this body was at point 1. And after 6 seconds, this body was at point 2. We need to calculate the average acceleration. And average acceleration by definition, this is the vector, which is equal to v2 minus v1 divided by delta t. So this is our velocity 2. So this is velocity vector at point 2. So this is our velocity 1. So this is velocity vector at point 1. And we do not care what happened in between. So this is average characteristic. And we are just interested what was in the beginning of this travel and what was at the end of this travel. And based on that, we calculate the change of velocity. Okay, delta t in this case is just t2 minus t1. So this is, as I mentioned, time of travel from point 1 to point 2. And this is 6 seconds minus 2. And this is equal to 4 seconds. 4 seconds, it took this body to travel from point 1 to point 2. Okay, so let's renotate our difference as delta v divided by delta t. And the only problem here is to calculate this vector right there. Okay, we are going to use geometric approach in this particular case. In the next video, we are going to use component approach. So here we are going to actually add these two vectors, even though we have minus sign here, so we can still represent it as the sum. Our delta v is equal to v2 plus minus v1. And minus v1 is the same vector as v1, so just flipped in the opposite direction. Okay, we are going to use tip to tail rule and then sine and cosine law to calculate everything like in the triangle, so which we are going to form after we apply that addition rule for these two vectors. Okay, so let's grab our vector here. So let's copy paste it right there. So let's put it, let's say, somewhere here. So this vector stays the same, absolutely the same. But this vector here, it will change its direction. Okay, it's going to be pointing in the opposite direction. So let's first move it into place. So this is going to be tip to tail rule. So we need to move it there. And let's put the direction opposite, right? So it's going to be opposite. Okay, so let's draw a couple of horizontal lines. Here, let's first draw the resultant, right? Our delta v in this triangle, so which will go from tail of the first vector to the tip of the second vector, according to our vector addition rule. Okay. So this is going to be our delta v. This vector here is 40 meters per second, so that's the magnitude, and this is minus v1 vector, and this vector stays the same, 55 meters per second, right? So this is our vector v2. Okay, so let's draw a couple of horizontal lines to define the angles in this triangle. Because right now it's not defined, right? We have two sides, but we need the angle between those two sides. So this angle here, so this is 15 degrees. This angle here is also 15 degrees. So since this is parallel to this. Okay, and this angle there, it is angle here, and this angle here is 50 degrees, right? So it's 50 degrees. Okay, so this is 50 degrees, and altogether this angle here gives us 65 degrees. Okay, good. So we have two sides and the angle in between. So it means that this triangle is set. And that means that we can calculate everything else in this triangle. Okay, to calculate delta V, we can apply cosine law. So this angle is also important because it will help us to define direction of our delta V vector, and this is also going to define direction of our average acceleration in combination with this 15 degrees angle. So this is going to be angle relative to the horizontal line. Okay, so let's apply cosine law. Our delta V squared is equal to 40 squared plus 55 squared minus 2 multiplied by 40 multiplied by 55 and multiplied by cosine of 65 degrees. So we can right away calculate our delta V. So let's use our calculator right there. Okay, so let's see. So we have 40 squared, right, plus 55 squared minus 2 multiplied by 40 multiplied by 55 multiplied, make sure that your calculator is in degrees, 65, and that's cosine of 65, right? Okay, so let's see how much is that, and we need to take the square root. Okay, so it's 52.6 up to the third significant figure, 52.6 meters per second. So that's not it, right? So we just defined the magnitude of this vector, but we also need some angle which defines its direction. So, and this is going to be our angle alpha plus 15 degrees. So we just need to calculate that angle alpha, and to calculate angle alpha, we are going to apply sine law. Okay, so we have 40 divided by sine of alpha, and this is equal to our delta V, so which we've just calculated, so it's 52.6 divided by sine of 65 degrees. Okay, so our sine alpha is equal to 40 multiplied by sine of 65 degrees divided by 52.6, and this is equal to 40 multiplied by 65, and sine of this angle, right, and divided by 52.6. Okay, so let's see. So this is 0 0.689. Okay, and let's take sine of that. So this is 43.6, right? So 43.6, or angle alpha is equal to 43.6 degrees. Okay, our delta V is equal to vector is equal to 52.6 meters per second, and pointing in this direction at 43.6 plus 15, and that gives us 58.6 degrees. Okay, so this is done. So then we can finish this calculation. So let's maybe do it different color. So let's finish this calculation. So our delta V is 52.6 divided by delta T, so which is 4, and this is equal to 52.6 divided by, okay, 13.15 up to the third significant figure. It's going to be 13.2 meters per second squared, and the angle is going to be the same, which is 58.6 degrees. Okay, so that's it. So this is the answer. So our average acceleration. So we can write down our answer here. Let's say our average acceleration vector is equal to 13.2 meters per second squared at 58.6 degrees relative to the horizontal line. Okay, so that's it. As you can see, it's relatively straightforward, and in the next video we are going to solve exact same problem, but we will apply component